Hello. In this section, we're still working on circles, and actually, this is going to be a very important video, very important part of the topic, which is looking at the equation of a circle, uh, which means can we write down a physical equation of a circle on a grid like this? And give in terms of x and y, right? Like with any other graph, right? Um, and I would say as well, if you did the AS pure uh, in the order of the chapters and from the textbook, so from chapter 1 to chapter 6 now, I'd say actually this is where it becomes A level maths at this point. You probably know it's a little bit of a step up now. In some of the things that we start to do and the sort of questions. But it should be okay. But anyway, that aside, so talk about equation of a circle then. At GCSE, you would have been familiar with this, where we have x squared and y squared is r squared. But that r is the radius, but also the centre would be at the origin. Okay, you worked with the centre of a circle being at 0, 0. Okay, so it looked a bit like this, right? So we had, there we are, a circle, there we are, that's centered at the origin there, okay? So you're familiar with that, right? And the idea of that, where that equation comes from is, and before we look into it, recall the distance formula between 2 points that we looked at in the last section with lines. So if we had a point, so if we have 2 points here, a line here, and the line between them, say we call this point x1, y1, and this point x2, y2, but then we call the distance d, the length of the line between them, the straight line distance between the points, was d is the root of the change in x, so x1 take away x2 all squared, add the change in y, okay, so y1 minus y2 all squared, okay. And so with that distance formula then, so if we then take any point on this circle here, on the circle, on the circumference, on the circle, any point whatsoever, say here, right, we call that the point P, say for a point, and then it has a general xy coordinate, right? Any x and y coordinate, and we could pick that point anywhere on the circle, like here, there, absolutely any points at all. But I'm going to take this particular point here. It doesn't matter, it works exactly the same way wherever we take it, right? Any xy coordinate. Now the way circles works is that from the center, from the middle of the circle, it's the same distance at any point on the outside of it. So and we call that the radius, right? So between here at the center and P, that would be the radius, that distance between 0 on the origin and P, and that would be the same no matter where on the outside of the circle we go from the center. Okay, if we go to any point outside the circle, all of these lines that are drew from the centre to the outside of the circle will always be the radius. Okay, that is the whole idea of a circle, is that it's the points where it's a distance of the radius from the middle. Okay, so let me just redraw that again, just to be a bit neater, to get back to where it was before. So then we have the centre at the origin again, and say we take this point P, and you have O there, and then, so therefore the distance was R for radius. Okay, well we can also use and that was point xy. Well, we can use this distance formula here, because these are 2 points, O to P, where P is xy, and O, the origin, is 0, 0, right? Well, we can work out the distance, and we know the distance is the radius R, right? Well, alternatively, if we use the distance formula, we know the distance has to be r, the radius. And so then we can do change in x. So let's take p. Let's start at p. Firstly, change in x is x minus 0, all squared. Then we add the change in y. So then we have y take away 0 all squared. Well, if we simplify that, we get r is just root x squared and y squared. And therefore, if we square both sides, we get x squared and y squared. By removing the root, we get r squared. And there we are, we get that formula there. Okay, cool. But then the question is, what if we move this centre anywhere at all on the grid? It doesn't have to be at the origin. What if it's anywhere at all? Well, then let's consider this again. So now let's consider a general circle. Okay, that is now at the with the centre AB. Okay, so its coordinates is AB for any value of A or any value of B whatsoever. Okay, so the centre could be the circle could be there, it could be there, it could be there, it could be anywhere on the grid whatsoever. Okay, we can go absolutely anywhere we want to. Again, then I'm going to take any given point P on the circle P, and then it's also going to have an XY coordinate again. Take any point on the outside, any point at all. Then we're going to do the same argument where again the idea is with a circle, the distance from the centre to the outside will always be the radius r. Okay, but therefore then, if we then let's connect the point AB to the point P, which is xy. That distance is going to be r for radius, but alternatively then, if we then use this distance formula, we get that r, the radius, is the same as the distance right between the 2 points. So that will then be the root of the change in x. So we have x, take away a, the other x coordinate, all squared, and the change in y. Then we do y, take away b, all squared. Cool, but then again, if we then just square both sides, we therefore get that x minus a all squared add y minus b all squared is equal to r squared, and that's the general formula for equation of a circle. Okay, so I'll make a note there. Equation of a circle, and this holds for absolutely any centre now whatsoever. Doesn't have to be at the origin. We can get the origin formula if we just take the centre to be 0, 0, and therefore a would be 0 and b would be 0. If we substitute that in, we would then get x minus 0 all squared add y minus b, well, b would be 0, so y minus 0 all squared to get r squared, and therefore simply then x squared and y squared equals r squared. So we get back that formula that we know and love. But yeah, and so with this formula, we would say that the centre is AB again. I'll just the centre was AB there as an example. But AB could be anything, right? But then and the radius is r. Okay, and why am I writing that here is because of the fact that the signs are kind of a bit misleading, because we have x, if we just stared at the formula, well, it's x minus a in the bracket, but here the centre is a for x, so it becomes a negative a to a positive a. Okay, so you have to do reverse the signs. Likewise, it's y minus b here, but here we have positive b, so again you need to pay attention to the signs. Okay, and then r is the radius, but here it's r squared. Okay, so we'd have to square root it to get back the radius. Okay, now it might seem a bit obvious, however, we will be seeing questions in a minute where they give us this formula here and you need to work out the centre, so you do need to pay attention when you're going backwards. Okay, but we'll be doing loads and loads and loads of examples in this video. Might be a bit of a long one, but this is an essential skill to practice, an essential topic. It's a key idea, and I reckon it should come up in your exam paper in some form, this exact topic that we're going over now. So it's very important to get your head around. Okay, let's have a look at some examples then. So first of all, it said write down the equation of a circle with centre 5, 7 and radius 4. So again, I'm going to make a note. The centre is 5, 7, radius is 4. Okay. Therefore, I need to use it's this equation I need to write down, the one I boxed. So it's going to look like x minus a, but the centre is a at 5, so we're going to do x take away 5 all squared. Then I'm going to do plus y it'd be take away the y coordinate b, so it'd be take away 7 all squared. Then it's telling me I need to get r squared, which is the radius squared. Well, the radius alone is 4, so radius squared would be 4 squared. Okay, so I can simplify that a little bit then to get x minus 5 all squared plus y minus 7 all squared is equal to 16. And that's your equation of the circle. Okay. Cool. Again, just pay attention to the signage where we had positive 5, positive 7. Then we had to do minus 5 and minus 7 in the bracket. Okay, so we needed to reverse the sign. And we needed to square the radius. Okay, because we had r squared here. Okay, there we are. Let's have a look at another example then. A circle has equation x minus 3 squared plus y plus 4 squared is 20. Part A says write down the centre and the radius of the circle. Okay, so we don't need to do much here because it says write down. So there's not really much maths or steps involved in this. So centre then, we should be able to just write down the answer then. Well, the centre again, if we have the formula here, x minus a all squared plus y minus b all squared equals r squared. And by the way, you will need to remember this. It's not in the formula book. However, when you get practice and used to it, it should hopefully start to come to memory. Anyway, this formula here, well, let's compare. You just compare it then, right? So we have x minus a, well, we have x minus 3, so the centre will be positive 3 for x. Then the y coordinate, well, y plus 4, y minus b, well, that'd be, instead of plus 4, we'd have minus 4 there, okay? So that's my centre then. Then the radius, well, we have equal to 20, but here it's r squared. So this is the 20 is the radius squared. So to get to the radius, we need to root 20, okay? So that'd be my radius for the circle. And that actually simplifies to, I believe, 2 root 5, is it? Yes, 2 root 5. Okay. There we are. So that's part A then. Part B, show that the circle passes through 5 minus 8. So again, this is an equation of the circle right here. X minus 3 all squared plus y plus 4 all squared equals 20. So that means that we can substitute points x, y into this equation. So here this point is 5 minus 8, so I'm going to sub 5 minus 8 in. And if it is on the circle, then that equation should be true, okay? So let's substitute x as 5 in, so we get 5 minus 3 all squared. Then we're going to add y, which is minus 8 plus 4 all squared. If you put all that in a calculator, you should get 20, hopefully. You get 20, okay? There we are. So equation is satisfied. Therefore, 5 minus 8 is on the circle. Cool. There we are then. Example 6. The line segment AB is the diameter of a circle where A and B are 4, 7 and minus 8, 3 respectively. Find the equation of the circle. So again, equation of a circle, x minus A all squared plus y minus B all squared equals r squared. We need a centre and we need a radius in order to have or come up with the equation of the circle. Let's have a look then. So we're given a line segment AB where A and B are 4, 7 minus 8, 3. It's a good idea. We did example like this last time actually. It's a good idea to then perhaps do just a quick little diagram of the line. So A is 4, 7. B is minus 8, 3. Now what we're also told is that AB is a diameter. Now remember last time we looked at if we had a diameter, the midpoint of the diameter must be the centre, okay? So we call that M for the midpoint. The centre is the midpoint because it's a diameter. Think about halfway through the diameter is at the centre, right? Because it splits up. The midpoint splits it into two radii, okay? And remember, the diameter has two lots of a radii. Anyway, so the diameter is the midpoint. Well, we know how to work out the midpoint, right? M for midpoint, the MP, but I'll just call it M. The midpoint between these 2 points is the average of the x and y coordinates. So let's add the x's together. We have 4 add minus 8, 4 minus 8 over 2, as it's an average over the 2 points. Then we do the same for y. We have 7 add 3 over 2. Okay, and then the midpoint, well, 4 minus 8 is minus 4 over 2, that'd be minus 2. 7 add 3 is 10 over 2, that'd be 5. So that's my midpoint, and that's also the centre, okay? Okay, so I'll start to fill in my equation then. Well, it's going to be x minus a, okay? But the centre is minus 2, okay? So it needs to be x minus minus 2 to be x plus 2, okay? All squared. Because remember, the centre is AB, so if my centre, the x, is minus 2, then it needs to be negative of that, okay, in the equation. So negative 2 would be plus 2. Then I have plus y. Then I'm going to do, well, it's 5 at the centre for y, so it's going to be minus 5, all squared. And that's going to be the radius squared. Well, we need to work out the radius, don't we? Well, how do we work out well, we're given actually a diameter, aren't we? We know that the diameter is double the radius. Well, I think we can work out the diameter, can't we? Because the diameter is the whole distance here between A and B. We know how to work out the distance between 2 points. We went over at the start actually. The diameter is going to be again the distance between A and B, the 2 points. So it's going to be first the change in x all squared. So let's take a, so 4 minus 8, so it's plus 8 all squared. And then add the change in y, that's going to be 7. Take away 3, so the change in y values. And that gives me my diameter if I put that in the calculator, right? So the root of 4 plus 8 all squared plus 7 minus 3 all squared. I get 4 root 10, okay? But that's the diameter. We know the radius is half the diameter. So therefore radius is 4 root 10 over 2, which goes to 2 root 10, okay? There we are. But then I can complete my equation to therefore get x plus 2 squared plus y minus 5 squared is this whole 2 root 10 all squared, okay, because it's radius squared, remember. Therefore, if we simplify this, we get x plus 2 all squared plus y minus 5 all squared is, if you put 2 root 10 squared in the calculator, you get 40, okay. There we are. There we are, we've got the equation there. Cool. Example 7 then. Okay, here we are. So you're not always going to be able to, you're not going to be always just given a nice little formula for it, or you're not going to be just given the centre and the radius. Sometimes you're going to get given an equation in this form here, and it looks, and we can convert that into this form here, which we know, which is the formula for the circle, the equation for the circle. But how do we get there? So we have to do a bit of work to get from this original equation, which looks a bit weird, to here. And how you do that is, if I rewrite this, what we're given, x squared and y squared is minus 14x plus 16y minus 12 equals 0. Okay, how do we get there? Well, does this not take this x minus a squared. Does that not look a bit familiar to completing the square that we did in the quadratics? I think it does. Remember we had a quadratic equation. I mean, it kind of does look like a quadratic, right? We have a quadratic in x, right? We have x squared plus minus 14x. In fact, let's move the x's to one side, right? So we're going to x squared minus 14x. Then the y part, so y squared plus 16y minus 12 equals 0. Well, it looks like a quadratic in x squared, right? An x squared quadratic and a y squared quadratic. And these look like completing the square, right, of both the x and the y quadratics. That's exactly what we're going to do. What we're going to do when you've got an equation like this, which, you know, also comes up fairly often, before you can deduce the centre and the radius to get it in this form, well, you need to complete the square. So you need to complete the square on the x terms and the y terms separately. So let's do that then. So we're going to complete the square. I remember we went over that in the quadratics chapter if you need a refresher. But if we complete the square on both the x and the y parts, well, remember we have a bracket of x, then we halve the x coefficient, so minus 14, half of that's minus 7, all squared. Then we do minus square root of square 7, so minus 49, okay? So that's complete the square next. Then we need to complete the square on the y part here. So then that's going to be plus, again, y, bracket, and then half of plus 16 is going to be plus 8, all squared, okay? Then we do minus 8 squared, so minus 64. Then we got minus 12 at the end here, okay? Don't forget that. And there we are. So then we could tidy this up a little bit by collecting all the numbers outside together. So we're going to get x minus 7 all squared. Then we're going to add the y plus 8 all squared. Then we're going to bring the numbers together. So we could get minus 49, minus 64, minus 12. And that gets you minus 125 equals 0. Well, it looks very, very similar now to this form. But here, the radius is on the other side. Well, that's this number here. Let's move that to the other side of the equation to get x minus 7 all squared plus y plus 8 all squared is equal to 125. There we are. Okay, cool. So now that looks like it. That looks in the form that we're used to for the equation. Therefore, if we read off the equation, well, the centre, then, well, the x coordinate's going to be the opposite of this. So minus 7 be plus 7. Okay. Then instead of plus 8 for y, it's going to be minus 8. Okay. There's our centre. And the radius, well, the radius r squared is 125. So the radius alone is the square root of that. Okay. And does that simplify? Yes, it does. It goes to 5 root 5. Okay. You don't need to do that, but yeah, there we are. There we are. So we've got a cent and the radius then. So yeah, when you got an expression that looks like this, all jumbled together of x and y, you complete the square on both the x and the y parts because they're both quadratics in x and y. And the best way to see that is to split the x parts together, bunch the x parts together, like I did here, and the y parts together to allow you to complete them separately. Okay, and therefore, eventually, then you get to the equation that we know. Okay, so we've got an exercise then, and I really, really, really want to practice this skill to really drill it down because it's quite important. You can recognise the cent and the radius and use the formula. So part A. We have x plus 5 squared, y minus 4 squared is 9 squared. Well, again, at the centre, first of all, well, again, it's going to be the opposite. So instead of plus 5 for x, we're going to get minus 5. Then instead of minus 4 for y, we get plus 4. Okay. And the radius, in this case, is going to be, the radius is r squared. But here, it says it's 9 squared. You could work that out to be 81. But actually that helped us out because it's going to be root 9 squared, right? If you square root this, because that's r squared, that's just 9, isn't it? So we don't have to work that out at all there. So there we are. Part B then. Okay, so we have x minus 7 squared, y minus 1. So first is the centre in this case. Well, instead of minus 7 for x, it's going to be plus 7 for the centre. Then we do the opposite again for y. So instead of minus 1 for y, we do plus 1 there, okay? And so the radius is then also going to be, well, if this is the radius squared is the 16, so it's going to be root 16, and we know that should be 4, okay? There we are. Let's do part C then. We have x plus 4 squared and y squared is 25. So the centre then, firstly, well, for x, instead of plus 4, it's minus 4. But y, oh, hang on, y, it's just y squared. But what you can say there, though, is it's kind of like the, you know, the formula for the circle at the origin, right? Well, that means y is at the origin. So y is 0, right? So instead of the centre, will be y0 for that part. And you can see that as well, because y squared is the same as y minus 0 squared. So therefore the centre must be 0, okay? Anyway, so then the radius then, well, again, the square radius is 25, so the radius alone is the square root. So root 25, which should be 5. Then part D, we have x plus 4a squared. So obviously we've got some algebra, we've got some letters, but again, exact same concept. And y plus a squared is 144a squared. So the centre in this case then, well again, instead of x plus 4a, it'd be minus 4a for the x coordinate centre. Then y plus a, the y will be minus a. There we are. And the radius would be, well, radius squared would be 144a squared, so the radius we need to square root that to get root 144a squared. Okay, well this requires a little bit of third laws, so remember we can split this up to root 144 times root a squared. So then root 144 is 12 times root a squared is just a, because a squared cancelled the root to get a, which is just 12a, and there we are. Then part E we have, okay, there we are. So part E then we have, oh my god. Part E then we have x minus 3 root 5 squared and y plus root 5 squared is equal to 25. But again, for the centre then, instead of x minus root 3 root 5, do the opposite. So we're going to add 3 root 5. And that's the x coordinate there. Then y, instead of plus root 5, we're going to do minus root 5. Okay, you can kind of think this as well by just setting the brackets to be 0. In a way, if it helps. So if x minus 3 root 5 is 0, then x has to equal 3 root 5. But it depends how you want to see it, really. So there we are, that's the centre. Then the radius, well, radius squared is 27. So the radius alone is root 27, okay? Does that simplify? Yeah, it goes to 3 root 3. There we are, cool. Okay, so that's a bit of a quick fire sort of thing, but hopefully you're getting a good idea now for how to deduce the centre and the radius of given from the equation, right? Okay, so now we're going to kind of work the opposite way. No, we're not. Sorry. We're gonna turn it up a gear then, like with the example we saw just a few minutes ago. Now we're given these funny expressions, and we need to find the centre and the radius again. Well, in this particular case, remember, now we need to complete the square. So on both the x parts and the y parts. So the first thing we want to do then is to split the x and the y separately. So group the x terms together and the y terms together after. So first we have x squared and y squared minus 2x plus 8y minus 8 is 0. Well, firstly let's group the x terms together. So we have x squared, then a minus 2x. Okay, then we do the y part, so we then add y squared, add the 8y. Then we have the minus 8 on the end. Okay, Then we're going to complete the square and the x and the y parts because they're both quadratics. Then we're going to get x minus a half of minus 2 be minus 1 all squared. Then we minus 1 squared, so minus 1. Then we do the same for y, so then a bracket of y, and then half of 8 is going to be plus 4 all squared. Then we minus 16. Okay, then we have the minus 8 on the end there. There we are. And that's equal to 0. Now we can just work out the numbers. So we have x minus 1 all squared plus y plus 4 all squared. And then minus 1 minus 9, minus 1 minus 16 minus 8 gets you minus 25, okay? Okay, but remember, we need to move this onto the other side because all the numbers on their own need to move to the other side to get the radius. So we have x minus 1 all squared plus y plus 4 all squared is equal to 25. Okay, well therefore then, hopefully then we can read off that the centre, now we've got it in this form, the centre again, so if we have x minus 1, it's going to be plus 1. Then y of plus 4, then the centre at y is minus 4. And the radius, well, the radius squared would be 25, so radius would be root 25, which is 5. Okay, cool. How much space do I have? Okay, I might have to squeeze in part B here. Okay, I need to make some room. Okay, part B then, we have x squared plus y squared plus 12x minus 4y is 9. So again, the same idea, we need to complete the square and the x and the y parts to get this in this bracket here. Okay, so then we need to group the x parts together. So if we x squared plus 12x, then we have plus y squared minus 4y equals 9. Okay. Then we then complete the square and the x and the y part. So firstly, x plus a half of 12 would be plus 6 all squared. Then we minus 36. Then we do add y. Half of minus 4 is minus 2. Then we minus 4, and that's going to equal to 9. Okay. Then we can collect the numbers. So we have x plus 6 all squared plus y minus 2 all squared. Then minus 36 minus 4 is minus 40 equals 9. Then we can move that number to the other side to get x plus 6 all squared plus y minus 2 all squared is equal to 49. Okay, if you add 40. Then we can read off from this at the centre, well, it's going to be minus 6 for x and plus 2 for y, because it's minus plus 6 goes to minus 6 and minus 2 goes to plus 2. And the radius, well, radius squared is 49, so radius would be root 49 to get 7, sorry, there. Okay, then part C, lastly, we have x squared and x squared plus y squared minus 6y is equal to 22x, was it? Yeah, 22x minus 40. Okay. Okay, so firstly, this is not really, we need to group the x and the y parts together, but it's a bit weird, so I could just move everything firstly to the one side of the equation. So let's do x squared, then we minus 22x, then we have y squared minus 6y, then we add 40, and that will then equal to 0, because we moved all of this to the other side of the equation. The right hand side moves to the left. Well, then we can complete the square on the x and the y parts. So then we have x minus a half of 22 is minus 11 all squared. Then 11 squared is 121, so it's minus 121. Then we do complete the square on the y, so y, and then a half of minus 6 is minus 3 all squared. Then we minus 3 squared is 9, and plus 40 equals 0. Okay, so if I add the numbers together, x minus 11 all squared, add y minus 3 all squared. So then adding the numbers, I get minus 121 minus 9 plus 40, that gets me minus 90 equals 0. Therefore, x minus 11 squared, add y minus 3 squared. If I move that to the other side, I get positive 90. Therefore, the centre then, minus 11 for x would be plus 11 here, And so minus 3 for y would be plus 3 there. And so therefore also the radius, but radius squared would be 90, so the radius alone would be root 90. That goes to 3 root 10. Cool. Okay, so we were then told here the point 4 minus 2 lies on the circle, and the circle has centre 8, 1. It's a bit weirdly worded sentence there. Find the equation of the circle. So we are told the centre is 8, 1. I guess you can draw a diagram if you want. 8, 1. And the point is 4 minus 2 there, right? So, well, technically it'd be there, but I'm not really fussed about plotting the point exactly. Okay, that's the situation we've got. Okay, if we draw the situation. Okay, so from this we need to deduce the equation of the circle. Again, with a circle we need the centre and we need a radius. But we know the centre, we're given that's 8, 1, but we don't know the radius yet. How would we work out the radius? Well, we're given a point on the outside and the centre. Again, then if we use the distance between that gives me the radius. There we are. Well then, how are we going to work that out? So the radius then, that's going to equal then the distance between the 2 points, right? And hopefully start to get familiar with that, because we'll be using that idea quite a lot in this chapter. That the fact that between 2 points from the outside of the circle to the centre, the distance is the radius. But yeah, so the radius then will first meet the change in x of the 2 points. So let's take the centre first. So x is 8, then take away 4, all squared. Then we add, changing y, so we have 1, take away minus 2, all squared. If we put that in the calculator, that goes to root of 8 minus 4 is just 4 squared. Then we add 1 minus a minus 2, that goes to a positive. So that would be plus 3, all squared. That gets me 5, okay. Cool. So now we've got our radius to be 5, okay. That's r is 5. Okay, and then we could just state the equation then. So remember, the equation is x minus a squared. Well, the centre's 8, so then it could be x minus 8 all squared. Then for y, we have y minus 1 all squared. And it's going to equal r squared. Now, radius is 5, so 5 squared. That's going to equal 25. Okay, there we are. Cool. Let's have a look at this example then. So we're given the line PQ, which is the diameter of a circle, where P and Q are 5, 6 and minus 2, 2 respectively. Again, find the equation of the circle. So again, if we're given 2 points, let's probably draw a little sketch of it. So we have point P here. Oh no, sorry, it's a point there and a point there. Say that's point P, which is 5, 6. Q, which is minus 2, 2. Again, I'm not worried about the actual accuracy of the line. If it's going downwards or slow, what the gradient is, I'm not worried. I just want to do a rough generic sketch of the line between P and Q. Okay, so that's the line between P and Q. Now, we're told that PQ is the diameter. Well, again, if it's a diameter, the midpoint, which we looked at last time, the midpoint M is going to be the centre, okay? So first we need to find the midpoint then. So the midpoint M, but again, if we add the two x values, so we're going to get 5 minus 2, and then that's over 2. Then we add the y value, so we have 6, add 2 over 2. That's going to get me 5 minus 2 is 3, so that'd be 3 over 2, and 6 plus 2 is 8. 8 over 2 is 4. Cool. So that's our centre then, okay? Therefore, the centre is also the midpoint, because it's the diameter in this case. And so that's 3 over 2, 4. Okay, but we also need a radius. Well, the radius, again, PQ is a diameter. Well, therefore, I can find the diameter by finding the distance between the points. So firstly, then the distance. So we do change in x. So let's do P. We have 5, then take away minus 2, all squared. Then they do the change in y, all squared. So we have 6, x, take away 2, all squared. Put that in the calculator, you get the diameter, the distance between the points to be, well, 5 minus minus 2 is plus 2, so that'd be 7, all squared, plus 6 minus 2 is 4 squared, so that's root 65. Okay, so that's the diameter, therefore the radius then is half the diameter, remember? So half of this is root 65 over 2, okay? There we are. Therefore, the equation then is going to be x minus 3 over 2, all squared, then add y minus 4, all squared, because positive 4 means we do minus 4 in the equation. So then that'd be radius squared, so it's going to be root 65 over 2 all squared. If you work that out, put that out in the calculator, you get 65 over 4. Okay, there we are. Okay, there we are. Cool. And there we are. Let's have a look at this. The point P, 7 minus 14, lies on the circle with equation this. Okay, so think about how we're going to deal with that. Complete the square. The point Q also lies on the point such that PQ is a diameter. Okay, so firstly, we give it, if you're given a diameter PQ, let's just draw the line PQ. So again, point there, that'll be P. Well, we're given P to be 7 minus 14. And Q, but we're not given anything about Q just yet. We're only given that Q's on the circle. We'll deal with that in a minute though. Okay. Well, firstly, I'm also given this equation here. Now, when you see that, it's going to link to the circle, right? That's the equation of a circle. When you see that come up, instinctively, you should then try to complete the square and find the equation of the circle, because they don't give you that for no reason, right? So let's do that. So we're going to have, and we'll see why we need that in a minute. So let's complete the square like we just did in the early examples. First, let's group the x terms together. So x squared plus 6x. Then we have plus y squared minus 14y equals 17. Then we're going to complete the square in the x part, so we have x plus a half of 6 will be plus 3, all squared, minus 3 squared is 9. Then add the y, half of minus 14 is minus 7, all squared. Then minus 7 squared is 49, and that's equals 17. Then we can add the numbers together, x plus 3 squared plus y minus 7 squared. Then minus 9 minus 49 equals minus 58. Equals 17. So therefore x plus 3 squared plus y minus 7 squared, that's equal to 17 add 58. And that's 75, okay. Cool. So then we can find the centre of the radius. Okay, but then let's go back to this, because we are going to need either the centre or the radius. In this case, let's have a look. Well, we are told that PQ is also a diameter, okay, again. Now, again, what do we know? If it's a diameter, again, think back to the early examples, PQ is a diameter, the halfway, the midpoint is also the centre, okay. But we know what the centre is. The centre, because we just worked out the equation of the circle. The centre is now at minus 3 from plus 3, and from minus 7 we get plus 7, okay, as the centre. But that's also the midpoint then, because if it's halfway in the diameter here, it's also the centre of the circle. So minus 3, 7. Therefore, I can fill this in to be minus 3, 7. But then I can work out the coordinates for Q, because I can work backwards. To work out the midpoint. So remember, if I then call Q, again, let's say a point xy, well then I can say, well, the midpoint between P and Q, but that's adding the Q and the x coordinate and the P coordinates together, right? So firstly add the x part, so you have 7, add x. Again, I don't know what x is, but let's call it x over 2. And then add the y part, so minus 14 from p. Add the y, and then that's over 2 as well. But we know the midpoint, okay, that's also has to equal what we did down here. Has to equal the point minus 3, 7. Well, therefore, I can get an equation for x and y. I can equate the x and the y coordinates of these 2 points, because the 2 points are the same, right? They're both just different ways of expressing the midpoint, but they're the exact same, so I can equate them together. Therefore, minus 3 is 7 plus x over 2, because that's both the x components of both of them. Therefore, minus 6 is 7 plus x. And so x, if I subtract 7, would be minus 13. And likewise for the y component, 7 is equal to minus 14 plus y over 2. Then 14 is minus 14 add y. If I then add 14 to both sides, I therefore get that y is 28. Cool. And there we are. So then the coordinates overall then, if q is xy, so q, x is minus 13, y is 28. There we are. Okay. So there's a lot going on there, but hopefully that all made sense, right? And why we did what we did, right? So the whole idea again that the diameter, the centre, the midpoint of it was the centre, but we could work out the centre from this equation of the circle, and then therefore from there we could then just solve to find the q coordinate. Okay, cool. Okay, let's have a look at this one, then we'll move on to some exam questions. But hopefully these examples have helped, the amount of examples I've done here. But anyway, let's have a look at this. A circle C has equation again of, say, x squared plus y squared plus 12x plus 2y is equal to k. Firstly, find the coordinates of the centre of C. Now again, it's in this sort of form of quadratics of x and y, so I need to complete the square to get to resemble the equation of a circle. Okay, get everything into brackets, right? Firstly, then I'm going to group the x parts together, so x squared plus 12x, then we have plus y squared plus 2y is equal to k. I'm not worried about this, it's just, k is just a number, right? I can leave that just where it is. And then I can complete the square on the x parts, so x plus a half of 12 is plus 6 squared, and minus 6 squared is 36, minus 36. Then we add y, and then a half of 2y is 1, well, half of 2 is 1 squared, then we minus 1 squared is minus 1 equal to k. Then I can add the numbers together, x plus 6 squared plus y plus 1 squared, and minus 36 minus 1 is minus 37 is equal to k. Therefore, x plus 6 squared plus y plus 1 squared equals k add 37, if I add the 37. And so therefore it's the equation that in the form I want it to be in. So therefore then I can read that for part 8, the centre, again, if it's plus 6 for x, it's going to be minus 6 at the centre. Then y is plus 1, it's going to be minus 1 there. Okay, there we are. So that's the coordinates of the centre. Then part B then says, state the range of possible values of k. Okay, interesting. Now, seeing that for the first time might throw you off, but hopefully it makes sense because it's fairly simple. Well, this is a radius, isn't it? Right? It's radius squared, but the whole idea is it's a length, right? Radius is a length. It's a physical thing, right? Now, because it's a length, it has to be positive. It cannot be negative, okay? A radius then has to be at least 0, okay, because it's a side, okay? A circle with a radius, a negative radius is nonsensical. It's not a thing. Every length has to be non-negative, right? It cannot be a negative. With that in mind then, if the radius has to be above 0, therefore radius squared has to be above 0 as well, right? That means k plus 37, which is the expression for radius squared, because remember, x blah 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 equals r squared, right? Well, that's equal to r squared again. Well, that means k plus 37 has to be at least 0, okay? Well, actually, no. It has to be above 0, because if it was equal to 0, well, the radius would be 0. That means you wouldn't have a circle. So the radius has to be above 0. It has to be positive, okay? In order for it to actually be a circle, a sensical circle. So actually it has to be greater than 0, okay? In order for the radius to be a positive quantity, okay? There we are, okay? And the radius squared will therefore be positive as well. Okay, so there we are. So hopefully that made sense, right? The idea that a length has to be above 0, has to be positive, okay? Then we can solve this inequality then. So the k, it has to be greater than minus 37. And there we are, that's our range, okay? Cool. So yeah, if they do ask a question, and we'll see another question like that in a minute. They do ask a question about this, and it says state the range. You need to consider the fact that r squared, whatever you get for r squared, has to be positive, and that's where you get your inequality from. Okay, there we are then. So let's have a look at some exam questions then. And also with exam questions, yes, they will ask you to find the coordinate of the centre and the radius usually. However, they might then require you to consider it geometrically to solve a geometric problem, which we will go into with some examples here. So let's have a look here. So firstly, the circle C has this equation. Find the coordinates of the centre. Well, again, we need to complete the square on this in order to find the centre, because we need the equation of the circle. So again, let's group the x parts together. So then we have x squared minus 6x, then plus y squared plus 10y plus k equals 0. Okay. Again, I'm not worried about the k at the moment. It's just a number. Anyway, so then we have x, and half of minus 6 is minus 3 all squared, and then minus 3 squared is minus 9, plus then all y, then half of 10 would be plus 5 all squared, then minus 25 plus k equals 0. Then we have x minus 3 all squared plus y plus 5 all squared, minus 9 minus 25 plus k. That's going to be plus k minus 34, I believe. Yes. And that's equal to 0. Therefore then, x minus 3 all squared plus y plus 5 all squared. That's going to equal then, remove the numbers to the other side, it'd be plus 34 now, minus k, okay? Because obviously we flip the sign if we move it to the other side. Anyway, there we are. It's in the equation now. X and y blah 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 all squared is equal to r squared, okay? Therefore then, I can deduce at the centre, well, if x is minus 3, it's going to be plus 3. Then y is plus 5, it'd be minus 5. Okay, that's cool. Part B then. So, given that C, the circle does not cut or touch the x-axis, find the range of possible values of k. So this is the sort of geometric stuff, and then in these sort of examples, it really is a good idea to sketch the circle of what you're given, okay? So we are told that the centre is 3 minus 5, okay? So we're going to sketch that then on our sort of axis, xy axis. There, x, y. Now the centre is going to be 3, well, x is 3, and minus 5 would be about there, okay? So that's my centre. Now, I don't know the radius, well, I do know it, but I don't know exactly because there's a k, it's an unknown there. So what in this situation, and often you do need, you need to consider the radius. So you need to, so the way to tackle that, if you don't know the radius, or you're trying to find a particular radius, like in this example, if you don't know the radius, just test them out and see what happens. So we are given that it cannot touch cross through the x-axis. It doesn't cross the x-axis, right? That means it can't touch up here. Okay, that's what that means. So then let's consider a bunch of radii. So if I do that, then if I expand the circle outwards, And then if I do it again, well, eventually it will go up there, but as there, okay. But when's that going to happen then? Well, again, it's going to happen if you consider the radius, right? It goes from the centre, and then let's assume, and then it does touch the x-axis, right? When would it touch the x-axis? When the radius, the length between the centre here and the x-axis, it's going to the radius. Well, the centre. Well, the height is the height, isn't it? Essentially, right? Well, if it's -5 down there, then that means that the origin at 0, well, the radius must be 5 then, right? Because the distance then from the centre upwards to 3 has to be 5, okay? Because the y value is -5 at the centre, and obviously on the x-axis y 0. So overall, you got the radius needs to go up to 5, okay? Now that's telling you when the radius is 5 again. Oh, it'll look a bit like this, but at that point, it's going to touch the x-axis. And if we go up by 5, increase the radius even more, the circle's going to expand outwards even more. And it will always then cross the x-axis, say there and somewhere there, okay? So that means the radius needs to be less than 5. So r has to be less than 5 in order to ensure this circle, which is centre here, no matter what radius you do, less than 5, will not touch the x-axis, okay? So, but we know an expression for the radius. The radius, well, the radius squared, so r squared we know is 34 minus k, right? So if r is less than 5 here, then that means that, well, we need r squared, not r. Well, you could square root this, I guess, to get r, but you can't really work with that. But what you can do instead is actually square this. So then we get r squared is 25, okay? Therefore, if r squared is 34 minus k, this means it has to be less than 25, okay? But then I can solve this for k. So then I get minus k is 25 minus 34. That's minus 9, okay? Therefore, I can then divide by -1. But remember, when you divide or times by -1 an inequality, you have to flip it. So k has to be greater than 9, okay? Cool, so that's my range of values. However, think about what we just spoke about. There's also a sort of obvious inequality as well, in that the radius r has to also be positive as well. Okay, obviously that's because of the fact radius is always a positive quantity, because it's a length, right? It's an actual physical side. So if r is 0, then obviously r squared is above 0 as well. And so therefore, if r squared is this, 34 minus k, that has to be above 0. So then I have minus k. Well, no, 34 would be greater than k. But I don't like it in this order, personally, because then I can flip it to then say k is less than 34, which makes more sense. I like it on the left of the inequality. Okay, so I've got these two there, these two inequalities. I can then combine these two. Actually, it might be okay. You could say k is less than 34, or k is greater than 9. Actually, no, it has to be and, right? Both of them have to be true. Okay, but then I can combine them, because this is saying, and remember when we did our work on inequalities, we looked at combining two inequalities together. So if we had k is greater than 9, that's saying k has to be above 9, but also this is saying k has to be less than 34. So 9 is like the lower limit, and 34 is the upper limit. So k has to be between 9 and 34. Okay, and that's my final inequality. Okay. That's a tricky question, okay? I think, for one, obviously, you might be a bit stuck, especially for the first time seeing it. You need to visualise, to sketch it, to work out when it crosses the x-axis. So it's tricky, perhaps, to work out that the radius squared needs to be less than 25. since the radius will be less than 5, in order for it to be below the x-axis to not touch it. But also they catch you out here, because not many people would realise that the radius would also have to be greater than 0. That's a given, but you do need to remember that to get the other inequality here. There we are. Cool. There we are. Let's have a look at another example then. So this exam question, a circle again has equation x squared and y squared minus 10x plus 16 is 80. Find the right coordinates of the centre and the radius. So hopefully again, you see the why drilling this in, it's the same sort of thing, right? Again, so firstly, again, we need to complete the square in order to get that in the form we want to find this centre and the radius. So we need to group the x parts together. So we're going to get x squared and then minus 10x. Then we add y squared plus 16y is equal to 80. Then we can complete the square and then x and y. So we have x, half of minus 10 is minus 5 all squared. Add y, half of 16 plus 8 all squared. And that's minus 64 is equal to 80. Oh, and should say minus 5 squared minus 25. My apologies there. I missed out that number. Okay, so then if we add the numbers together, we get x minus 5 all squared. Then then add y plus 8 all squared. Then minus 25 minus 64 gets you minus 89 equals 80. Therefore, x minus 5 all squared plus y plus 8 all squared. Well, I'm going to move the 89 to the other side, because then 80 add 89 gets me 169. Cool. Okay, well therefore then I can deduce that the centre, again, if it's minus 5 there, it's going to be plus 5, and if it's plus 8 here, it's going to be minus 8. Okay, cool. And so the radius then, well, if it's radius squared is 169, so it's going to be root 169, and that actually turns out to be 13. Cool. Then let's have a look at part B. Again, a geometric sort of issue here. Given that P is the point on the circle that is furthest away from the origin O, find the exact length OP again. So we should sketch this. It will help us massively. So again, we have our. Let's plot the circle again. Say here. Oh, awkward circle. Awkward axis even. X, Y. So for our circle, then the centre is at 5 minus 8. So 5 is, say, there. Minus 8 will be down there somewhere, right? Now, the radius is 13. To draw an accurate-ish sketch, if the radius is 13, well, firstly, this gap here is 5, because that corresponds to the x-axis. So it's going to be 8 away. So it's going to be over here somewhere, right? Because that's where the edge of the circle will be. Okay. Likewise, if this is if we gone from minus 8 to 0, the x-axis, if the radius is 13, we need to go from 8 to the and then we need to go up by another 5. Okay. So it's gonna the other edge of the circle is going to be up there somewhere. Okay. Then again, if we then use symmetry, I guess the other part of the circle will be down there, and the other end of the circle will be there. So if we form a circle that passes through these 4 edge points, we have a circle that looks a bit like this. Okay, it's a massive circle. It's an awful circle as well. Try that a bit better. Okay, there we are. Okay, although you might want to lower the size if you were to draw it, but anyway, there we are. Now what we are told is that P is the point on the circle that's furthest away from the origin. Now the origin is here, right? That's the origin. So if we draw from the origin to any point on the circumference, to any point on the circle, where's the furthest away it's going to be, right? And actually, I guess if you think about it a little bit, well, what it turns out is that if this is the centre, right, that we're drawn here, which is 5 minus 8, it turns out that if you want to deal with the furthest distance, it has to cross through the centre, because the distance, the furthest distance in the circle, is going to correspond to the diameter, okay? So if it passes through the centre, it's going to be on the diameter, because remember, diameter of a circle passes through the centre. And that's because of the idea that if it, for any chord on the circle, right? Remember, a chord is just any line in the circle, say here, or here, or here, or here. Now, what I'm going to do is sketch the circle again. If I have a diameter here, okay, well, say the centre's here, have this chord here, then have this chord here. The chords are getting larger, right? But then eventually I have a diameter, which is also a chord. Now the diameter will always be the largest chord in the circle, okay? So with that in mind, to get the furthest distance to the outside of the circle, if we're inside the circle, we're going to have to go on the diameter, okay? So it's going to have to pass through the centre, and then from the centre to whatever this point is, okay, which would then be P, okay, roughly. Now, we don't need to find P, really, well, we couldn't really find it anyway, but what we can use instead, we do need to find the distance from O to P, okay. Again, if you draw a sort of line from O to P, the origin, well, again, it's not a diameter, because obviously the diameter would also include from go to another point on the centre. I'm on the diameter, but I'm not. But this line OP isn't the whole diameter. Anyway, this distance, and I want to work out OP. This way I have to get a bit creative, but again, it has to pass through the centre. So the centre will be there somewhere. Not necessarily the midpoint, because again, it's not the whole diameter. It's just part of it. So the centre won't exactly be the middle. But it passes through the centre, okay? Now, we want to work out OP, but we can also alternatively consider splitting the lengths up into these two components, from O to the centre and from the centre to P. Because we actually know what these two parts are. O to the centre, well, we do know what O, which is 0, 0, and the centre, which we worked out in part A to be 5 minus 8. These are 2 points. I can work out the distance between O and the centre using the distance formula. What about then from the centre to P? Well, that's just the radius, isn't it? And I also worked out the radius in part A. That was 13. Therefore, then I can easily find OP. So then, to find OP, then I need to find the distance from the origin. The origin, which was 0, 0, to the centre, which is 5 minus 8. So that's going to be the root of, again, the change in x, first of all, so 5 take away 0, all squared. Then the change in y, so it's minus 8. Add minus 0, all squared, and that will get me, if I put that in the calculator, root of 5 squared plus minus 8 squared, 8 squared. And that's root 89, okay? Cool. There we are. So therefore then, this distance here, this distance here is root 89. If we get rid of this now. Well, therefore OP is just addition of these two. So therefore OP is root 89, add the radius on, which is 13. There we are. It doesn't ask it has to give the exact length, so don't use decimals. Leave it as a third, okay, as a square root. There we are then. Okay, quite a mean 2 marks again, but again, once you draw the situation, hopefully that does help you out a bit more. And again, another tip, exam tip, especially with circles. Sometimes you will need to consider split. If you want to find out a particular length, you might need to consider splitting it up into several parts, which you can work out individually. So maybe perhaps consider splitting it up from the centre instead, and then go from there instead of trying to work out the whole length, which you might not be able to do. Okay, cool. Final question then. Okay, and this question again is a hard one. Again, this was I remember this was probably the hardest question that was in that exam series. So yeah, but let's not be put off by it. Again, we're given a cut circle C1 has this equation: x squared y squared minus 6x 14y 33 is equal to 0. Again, part A, as usual, find the coordinates of the centre and the radius. Firstly, I'm going to restate x squared and y squared minus 6x plus 14y plus 33 equals 0. Then, well, to find the centre and the radius, again, we need to complete the square. So we're going to group the x part, so x squared minus 6x, add y squared plus 14y plus 33 equals 0. Then a complete square on x would be x minus half of 6 minus 3 all squared minus 9. Then add y, half of 14 plus 7 all squared minus 49 plus 33 equals 0. Okay, then we add the numbers to x minus 3 squared, add y plus 7 all squared, then the numbers minus 9 minus 49, add 33 gets me minus 25, okay, equals 0. Therefore, x minus 3 all squared plus y plus 7 all squared equals positive 25. From that, I can then deduce that the centre is going to be, well, if it's minus 3 here, it's going to be plus 3 for x, and then if it's plus 7 for y here, it's going to be minus 7 for y at the centre. And the radius then, well, radius squared again is 25 at the end, so radius is going to be square root of that, which is going to be plus 5. Cool. Okay, so hopefully that's fairly, hopefully this all makes sense at this point now, as we've done a load of examples of finding the centre and so on. Okay, now we're given a different circle C2, which has a centre with coordinates minus 6, minus 8, and the radius of k, where k is a constant. Given that C1 and C2 intersect at 2 distinct points, find the range of values of k, give the answer to set notation. Again, so let's draw the situation. So let's draw our two circles. So let's draw a big grid here. There we are. But first, let's draw this circle C1. So the centre is at 3 minus 7. So 3 is there, minus 7 would be, if we continue this on down here, it would be probably about there somewhere. Cool. And again, if it has a radius of 5, well, firstly, we have to go up by 5. So from minus 7, it would go to minus 2 there, okay? So that's 1 point. Then then if we go to where we can go to the left, so the furthest left point, again, if we go 5 units left, because that's the radius, from 3 it would go to minus 2, okay? So it would be, if minus 2 says there, another point on the edge would be there that I have to cross through, and then if you can use symmetry, we can kind of work out where the other points are, say here and here. And then if we draw a circle past those 4 points outside, we get this. Oh, what is that? That's not a circle. There we are. It's probably as good as it's going to get. So that's the centre at 3 minus 7. Okay, cool. Okay, cool. Now, this circle C2, we are given the centre is minus 6, minus 8. So minus 6 would be about there, and minus 8 would be there. So it would be there. That would be the centre in that case, okay? But we're not given a radius. It told us the radius is k, okay? So again, what we can consider here is what happens when we just increase the radius. So say we start here, then the radius goes up and then it goes up here. Then it goes up here again, and then eventually what will happen is it will start to touch the circle. Okay, you can see that there. Then when we go further than that, it will start to cross the circle twice. Okay, so what we need to consider then is the point where it starts to cross the circle twice. So let's consider where it crosses once here. When does the two circles cross once? Okay, again, it was this point here roughly. Well, when it happens once, again, this point, if we draw it again, roughly like that, that corresponds to the radius k, doesn't it? That corresponds to the radius of this circle C2 here. So in order for the circle, the two circles to cross once, by the way, it says intersect at two distinct points, so that's why we're considering when they intersect or overlap. Okay. So when they cross once here, that occurs, as we can see here, when the centre, it's the radius, right? When the radius of this circle allows this to be the centre to the outside point of the other circle here. Okay. So how would we find this radius then? This distance between here, the circle, the centre, which again is -6 minus 8. Let me write that a bit more neatly. -6 minus 8, and to this given point here, I don't know what the point is, but all I know is this is the point where it crosses once. I'm not interested what it is though, but I need to find this radius here, which should be k, because the radius was given to be k, remember, in the question. Because okay, but how would I work that out? And again, that goes back to the exam tip I talked about earlier, just where if you can't find a particular distance or 2 points, you can split it up to somehow between a centre and a radius, right? So the radius was there and the centre was there. Let's try and do that approach here, okay? So what if instead... so what we've got going on essentially, if I draw the situation again, when they cross over in this way, we have the centre here and the centre there, okay? Well, no, the centre the centre's there, let's say. So that's the circle C1 that we draw, and that's the circle C2 here, okay? So I want this length here, because that's the radius of C2, okay? So that'd be K, okay? But what I could also alternatively, what if I then just consider, get rid of this, what if I just consider the line connecting the two centres, right, instead? Then to get this portion here, that would be K. What if I consider the whole distance here, minus this distance here? This distance, I know, that's the radius of C1. The radius we worked out to be 5. Okay, that's the radius of C1. Oh, if I draw that again, oh god, there we are. That radius there is a bit small to see. I apologise, but from this centre at C1, which we worked out, to the edge of that circle, the radius of that is 5. We worked that one out. But then what about this whole distance here? Well, that's the distance. That's the distance between the two centres. But we know what the two centres are. Given at C2, this centre is -6 minus 8, and for circle 1, we know that's the centre. So now we can work out the distance of that centre. So essentially what's going on, again, let's just draw the line. We have the centre C2, I'll call that C2, and then we have C1. I want to find this cut-off point K when they intersect. Alternatively, if this is the distance, if that is the distance K, then this would be, then that would be the radius of C1, that would be 5, and the overall distance is the distance between point C2 and C1, I can then find k from that, okay, by splitting up into two parts. So, with that in mind, firstly then, the distance from the centre at C2, which was -6, -8, to the centre at C1, which was 3, -7, we can do that by a distance formula. We know how to do that, right? So therefore, that would be the distance of the change in x, so -6 take away 3 all squared, add the change in y, which is -8 take away -7 all squared. Put that in a calculator, you should get that's equal to -8, that would be +7, right? Double negative. That's root 82. Cool. Okay, so now we've got that. So we've got this distance then to be root 82. If we know this whole distance 82 from C2 to C1, we know the distance from this point here, the cut-off point, the intersection, to then the centre is 5 at C1. I can work out this distance here. Right, I can work out this distance here. Isn't that distance then, therefore, going to be that k is going to equal, in this case, the whole distance root 82 take away this part of the distance, which is 5. Okay, there we are. So so the radius of C2 is this for k. That means they intersect once, as you can see there. And we saw if we then increased the radius to be more than that, so say if we did it more than that here, that means that ensures that we get 2 intersection points, which is what we want. So that means k has to be bigger than this. So k has to be bigger than root 82 minus 5, okay? You might think we stop there, but then this is where they catch you off again. So you need to really consider everything. What happens when you keep making it bigger, okay? If we make it bigger, like that, oh, that's a rough circle, obviously it still intersects twice, but hopefully you start to see, if you make it even bigger, let's go up, if you make it absolutely massive, as like this, oh god, if you make the circle absolutely massive, oh, that's it's going to start to include the circle, isn't it? So therefore it's not going to intersect the circle C1 at all. So therefore there'll be no intersection. So actually then we need to consider an upper limit as well, where we can't make the radius of the circle C2 to be bigger than it. So then there's a cutoff point. So then it's going to perhaps look like this, right? The cutoff point where it starts to have 2 intersections to 1, is perhaps going to look like that, right? Where then there's only 1 intersection, and then if we make it any bigger than that, then it's going to have no intersections, because the whole the circle will be inside this C2 circle, the other one. So then we need to consider that as well. What value, what radius? Again, the radius would be from here to there, right? And so again, it's a similar sort of argument. I then want my radius, the whole. So what I have here then is, in this situation, if I then get rid of this, draw in here, the situation I have here, when it starts to become bigger than the circle C1, is here. Oh, that's an awful circle. There we are. So that's the whole of C2, and C1 there, right, and has like 1 cut off intersection point there. So the centre of that's also going to be 3 minus 7 again, and the centre is going to be about there, right? And again, like with the other example we just did, if you want the furthest distance in the circle itself, it has to go through the diameter. Okay, so it has to cross through the centre. Meaning, if we want the largest distance here, it needs to go through the centres, okay, to be on the diameter, okay. So so it has to pass through the centre of C1, okay. to get the largest line, the largest distance within a circle, if that makes any sense. So therefore, what we have then is this whole line is now K, which is what we want, the whole radius, but also we can split this up between the centres again, the distance between the two centres, which we worked out, it's root 82 here, right? We already worked that out, so that's cool. But we also then want this other distance here, but that's just the centre to the, that's just the radius of the other circle, which is 5, right? From the centre to the outside of the other circle, okay? That whole distance then is K, the radius of C2, okay? So the upper limit is when K is equal to root 82 plus 5 in that case. Because then I add the two components here and here, right? To get the whole line in that case. Okay, we're pretty much done there, because then that means if I go any bigger than that radius, then again this engulfing situation happens when the two circles, well, the bigger circle, the C2 circle, is the circle C1 is entirely in C2, which means there won't be intersecting, okay? Which means I need it to be less than this, so K has to be less than root 82 plus 5. And there we are, those are our two values, okay? Now also, obviously, as we discussed, because K is a radius, again, a radius has to be, a radius has to be, again, bigger than 0. So that means K has to be bigger than 0, but K has to be bigger than this quantity here. Root 82 minus 5 is bigger than 0, so it's already implied that K is bigger than 0 in this instance. So we've already done this, okay? So these are two inequalities. Okay, that's absolutely brutal question. But again, hopefully the idea that I'm trying to get across here is you consider the radius, you consider changing the radius and then expanding the circle to see what happens to the situation, okay, and see what you're interested in, what radius are you interested in to solve the problem. So we're interested in when we expanded C2, again, let me get rid of this now. When we expanded C2, starts here. When we start expanding C2 with bigger radius, then we start to see where it intersects the circle. And also the other strategy where we can split up what's it called? We can split, if we want to find the distance, a particular distance, we can split it up into the centre to consider that separately. Okay, but yeah, so then it says the range of values of K, which we did. Right, the answer is set notation. Okay, so one final step. Okay, but actually, again, both of it needs to be K greater than root 82 minus 5, and K has to be less than root 82 plus 5. We need to combine these inequalities together. So if K has to be above this number, so that means that's the lower bound. So 82 minus 5 has to be less than K, but then K has to be less than its upper number, root 82 plus 5, okay? Then therefore in set notation, again, remember we covered set notation, we looked at solving inequalities. When we give an inequality like this as a set notation, it's the same as a curly bracket of the values of K, such that then, and then we copy this inequality in. Root 82 minus 5 has to be less than K, has to be less than root 82 plus 5, okay? So then that's a curly bracket, so that stands for the set of values of K, and then this colon means such that, and then K has to be between these two numbers. There we are. Okay, final monster question dealt with. But yeah, there is no, there's no formulaic pattern to solving these. These are, geometric problems. You kind of just have to sketch the graph and try and work out what you need to do from there. However, some some sort of general, well, not general-ish tips is to sketch the circle or the problem or whatever, Then you consider ch changing the radius. So again, what happens if you increase the radius of the circle? What would that look like? And eventually, does that solve the problem that you want? So does that eventually intersect with another circle? Does that eventually intersect an axis or something like that? And also consider splitting a line into different parts, right? To find a distance. And again, I echo what we did in the previous question and that question. But the previous question, where if we needed to find the line from O to P, we couldn't find that directly because we don't know what the point P was. All we know is that it was on the circle. But if we split it up to then between the centre and then from the centre to P, we can then consider the radius from the centre to P, which again was 13, and then also this first bit from the centre, the origin to the centre, and we know what those two coordinates were, the origin and the centre. That allowed us to use the distance formula. Okay, so therefore we've worked out these two individual distances, so we could add them together to find the overall which we wanted, even though we didn't know what the overall was directly. Okay, there we are. Okay. So that is equation, and you might even need to perhaps use again the idea that we used that the diameter is the largest chord, or I guess not line, in a circle. Okay. So again, go back to what I briefly described earlier. Again, if you have a circle, a chord is obviously just any line in a circle. It goes to 2 points. So say you have a chord there, and then a chord there. Obviously, hopefully you know it's getting bigger. And then if it's a centre, the diameter. Oh, that's just not a straight line. The diameter will always be the biggest chord or the biggest line in a circle. And again, that helped us in these two questions. And again, if we go back to this one. Where was it? Yeah, this one here. So from O to P here, I wanted the point to be the furthest away, so I needed to be the biggest distance in the circle. To get the biggest distance in the circle, it needs to be on the diameter, which means it then has to go for the centre. Okay, so you might have problems where you need to consider the diameter. Okay, but yeah. So yeah, that is circles then. And that's just some general advice, I guess, if you need to deal with like a geometric problem, if they throw one at you. Circle. So yeah, so the main bit is this formula here at the very start, right? Where if you're given that equation of a circle, and again we might need to complete the square on it, but if you've got the equation of a circle looking at that, you can then deduce the centre and the radius, okay? And perhaps then they might throw in a geometric problem and you need to sketch this circle and see what happens, okay? So you might need to consider changing the radius and see what happens. But yeah, that's it for now. So I'll see you next time.